Question 43, North Carolina Math 1 release items, calculator active. The vertices of a rectangle are located at 1, 2, 5, 0, 2, negative 6, and negative 2, negative 4. What is the area of the rectangle? Well, as always, you should pause and try this one on your own. Get some graph paper out or Desmos, excuse me, and see if you can figure it out. All right, we're going to go over this one now in 3, 2, 1. Let me introduce you to my friend Polygon. Have you met Polygon? Here's Polygon. You spell out the word Polygon, P-O-L-Y-G-O-N, parenthesis, parenthesis, 1, 2, close parenthesis, comma, parenthesis, 5, 0, close parenthesis, comma, parenthesis, 2, comma, negative 6, comma, parenthesis, negative 2, comma, negative 4. Bet you didn't know you could do that, did you? Now, I'm going to do this without any formal distance formula. We know area of a rectangle is length times width, but y'all, the length and the width are diagonals, so we'd have to use Pythagorean theorem or distance formula to get those. Instead, let's focus on breaking this up into shapes we know, we're familiar with. And so it looks like my units are being counted by 1. Sorry, I'm trying to zoom out here. Let me do that 1 there and 1. Okay, so now we can kind of formally figure out what the area is. Let me hide those grid lines. Cool. We can literally count the number of boxes and try to figure it out. It's going to be a little bit hard to do, so we're gonna use some area formulas to help us along the way. So I'm gonna section this off into triangles and rectangles. So here's a triangle here, and that's going to have a base of 1, 2, 3, 4, 5, and a height of 1, 2. So the area of this is going to be base times height divided by 2. So 5 times 2 divided by 2, which is going to be 10 divided by 2, which is 5. So I know this area is going to be 5. And I'm going to break it up into another triangle. So this starts at 0, goes down to negative 6. So that's going to be 6. This is going to be 1, 2, 3, 6 by 3. And again, area of a triangle is base times height divided by 2. So 3 times 6 divided by 2, which is 18 divided by 2, which is 9. Okay, so we have 5, 9. Let's see what else we can do. I see a rectangle right inside. Now this only goes down 5. So this is going to be 5 by 2. And 5 times 2 is going to be 10. Area of a rectangle is just length times width. So no dividing by 2 here. So that's going to be 10. And I see 2 more triangles. So this little baby one right down there is a 2 by 1. So 2 times 1 divided by 2, that's only going to have a unit of 1. You can actually just look at it. I mean, you can see it takes up, if you flip this one over here, it's going to take up 1 square unit. So that's going to be 1 there. And then finally, I have this triangle, which is 1, 2, 3, 4, 5 by 2. So this is going to be base times height, 5 times 2 divided by 2. It's the same area as this triangle up here, which is going to be 5. So if I add up all my areas, I should have my total area. So I have 5. Let me use a different color here. So I have 5. I have 9. I have 10. I got 1. And I got another 5. So let's add these up. You can use a calculator if you want. That's going to be 14, 11, and then another 5. So that's going to be 14 plus 11. That's going to be 25 plus 5. All that should add to 30. So my area should just be 30 square units. Did that without doing any formal distance or anything, just breaking it up into shapes we know. Now, if you want to do this more as a formulaic way, just stick around. If you think you got it from breaking up the shapes, move on to the next question. All right, so how do I do this with formula? So let me clear all this out. We know the answer is 30. Let's see if we can recreate that answer. So remember, the area of a rectangle is simply length times width. Now I can get my length, it doesn't matter which one you call the length or the width, but I can get my length and width using Pythagorean theorem or distance formula. I find on a graph it's just easier to do Pythagorean theorem. So remember, you can do like a squared plus b squared equals c squared. Your hypotenuse would be the diagonal, so the length here. So I would do, in this case, 3, 1, 2, 3, 4, 5, 6. So my length is going to be, let's see, my length squared is going to be 3 squared plus 6 squared. My length squared is 3 squared plus 6 squared. So my length squared is going to be 9 plus 36, and my length squared is going to be 45. So my length is going to be the square root of 45. And you can get a decimal approximation of that if you would like. I'm going to do the same thing for my width. So this is going to be the square root of 45. And I'm going to find another right triangle that I can pull out from the width here. And so I can see here, maybe I'll use this one, where that's going to be 2 by 1, 2, 3, 4. So my width squared is equal to 2 squared plus 4 squared. So my width squared is equal to 4 plus 16, which is equal to 20. So my width is going to be the square root of 20. So I can get my answer by multiplying my length times my width. So if I know my length and width respectively are the square root of 45 and the square root of 20, I could then multiply those out to get my answer. And of course, that's not something I'm going to do in my head, so I'm going to go into Desmos and take care of that for me. So I'm going to do the square root, SQRT, square root, again, SQRT. Did you know you could do that? Square root, or you could go into here and do the square root symbol. If I can find it underneath all this stuff. So square root is right here, 45, which is about 6.708. And then you multiply Shift 8, or you can go into do your times symbol into here, right there. And then you do the square root of 20. And that does give you 30. And why does it give you 30? Well, 45 times 20 is 900, and the square root of 900 is 30. The square root of 9 is 3, so the square root of 900 is 30. So two ways to get that answer. I don't know which way is better for you, but you pick whatever makes the most sense, and you got your answer.